Tony asked me to talk about radio operations for balloons. And so I started working on that. And the first thing I did is I went and Googled balloon radios and found this neat thing right here on Amazon. But I'll talk about the radios that we use on the ground, the radios that we use in the air for different kinds of balloons. And I thought this would be interesting to the group. What I want to talk about as far as balloons is the high altitude, amateur high altitude balloons, pico balloons, and if we have time at the end, I'll talk a little bit about weather balloons. And here's examples of each of those. There's a pico balloon right there. There's a weather balloon, and I've got some goodies here that I'll try to hold up and show you as we go along, pass them around, I guess, too. Okay, and then what kind of operations? When I started thinking about radios with balloons, there's radios on the ground and there's radios in the air. And I'll talk about some of the details on each of those. There we go. Let's start out with high altitude latex balloons. These are the balloons. Edge of Space Sciences is big here in Denver. And it's the Poor Man's Space Program for students or for individuals. You can launch a balloon, it'll go up, you can track it, usually using APRS. It bursts when it gets to way up there, it parachutes down, and then you can go and get your stuff back. So students that have experiments can get them back, you can get your radios back, neat things like that. Here's one of the balloons, that's about 9 feet tall. It's about 9 feet in diameter, about 10 feet tall. When it goes up in the air, it expands to about 47 feet in diameter, and then it bursts.
What kind of payload does it carry?
You carry a string of payloads underneath it. Students build things that sample the atmosphere, that measure ultraviolet, that fly. We don't let them fly animals, but they fly yeast and then bake it into bread afterwards and fun stuff like that. Cockroaches, we used to do cockroaches, but I don't think we even allow that anymore.
And you don't allow cow.
What's that?
You got some.
The balloons start out, here's a typical thing, takes about 90 minutes, goes up to around 100,000 feet until it bursts, and then it comes down on a parachute in about 45 minutes. We start out usually at Deer Trail, Colorado, which is out east on Interstate 70, because that's outside the 35-mile Class B airspace for DIA. FAA likes when we stay out of that. The balloon goes out to the east, depending on how the winds are going. It bursts somewhere up there in the middle, and then it comes down on the parachute, and usually lands out east. In this case, it made it out to well, on I-70, we're out past Flagler, Siebert, out there. So it ends up being about 250, 300-mile drive a day when you get done tracking it and everything. But there's a couple of ways you can do high altitude balloons. You can do an organized flight, such as what Edge of Space Sciences does. We work with various student programs, high schools, colleges. We're coming into our big season right now in October and November because it's end of semester. Students have been putting it together. It's usually months in preparation. We schedule and plan on the balloons for months in advance. The students have been working on them, the college programs all semester. And here's an example of the students all lined up with their payloads that they have built on the string. We have one of our beacons on the bottom, one of our beacons and the parachute up on the top, string going up, and then the balloon. 5, 4, 3, 2, 1, let it go. It goes up from the kids and away it goes. We coordinate with the FAA. If the balloon is big enough, we're required to communicate with the FAA. If it's small enough, you don't have to, but we still do let them know.
Jim, somebody asked about the weight.
George was asking, or somebody was asking about the weight. Total weight of the payload string underneath is about 29 pounds. In a case like this, if you want a balloon that's exempt from most of the FAA requirements, it can't be more than 12 pounds. So you've got to keep things fairly light. Most of the student payloads, we let them be about well, a kilogram, which is 2 pounds. Try to keep it, a little bit less than that, so maybe 1.5 pounds, with their experiments and stuff in it. And, yeah, we have designated launch sites. We usually launch from, Deer Trail. It's got a nice school there. The guy comes and opens it up, lets us use the bathrooms. Some of the boys were smoking in the bathroom. That caused a little bit of a problem. And the other way you can do a high altitude latex balloon is do one on your own. You can buy the balloon, a smaller balloon for on the order of $30. Get a cylinder of helium or hydrogen. We use hydrogen. Build a payload, go out in your car to somewhere and launch the balloon. Then you can track it and recover it yourself. Small latex balloon, home built or a purchased beacon. You can buy beacons commercially that will work on APRS if you want. You can launch from pretty much anywhere. The FAA regulations say the first 1,000 feet you shouldn't be over an urban area. So ideally, you shouldn't launch from a park here in town, but people do. And then tracking and recovering on your own can be easy, can be difficult. If you want to be successful, proper prior planning prevents poor performance. Actually, there's one other P in there. I'm not sure what that says, but what you need to do is you need to know roughly where it's going to land and be out there to catch it. Because if you launch it and then try to chase it, and it gets up in the jet stream, it's going 120 miles an hour that day, you're going to have trouble chasing it. Usually you can't. And the other thing, you need to know how much gas to put in the balloon. If you just fill up a balloon until it kind of floats and let it go, it'll probably go up too slow. And if it goes up slow, it's going to go a long ways in the wind. One of the high school groups decided they were going to do their own. They ended up down in Lamar. People end up in mid-Nebraska trying to get their balloons back. So if you fill it up right, we try to get ours to go up about like 1,300 feet a minute. And then you can tell the prediction program what it's going to do. The prediction program will look at the winds and then give you an idea of where the balloon's going to go. And the way you do this is you go to a place called habhub.org, highaltitudeballoonhub.org, and they have calculators in there where you can put in where you're going to launch from, how fast you're going to go up, how high you're going to burst, and it'll tell you what your path is going to be and where you're going to come down. The other thing is you can tell it what size balloon you've got, how much the payloads weigh, and it'll tell you, here's how much neck lift you need to generate. And you can put a bag with lead shot in it, or any pennies or something like that, to give you that exact weight, and then you can fill up the balloon just until it kind of floats. It's a little tough to do on a windy day, but anyway, this is kind of an overview of the flying. But if you get all this put together, you can fly a balloon. And I've seen people in the past use an iPhone to track the balloon. What they do is they put their iPhone up there and you turn on what is Find My Friends, and it'll tell you where it goes. Pretty nice. You better be able to get it back, or you're not going to get your iPhone back. But there is one problem with that, and that's the telecommunication regulations still prohibit the use of cell phones above the ground. And that's back from the old days, I guess, when the cell phone systems weren't as sophisticated as they are now. And if you in a plane, it kind of goes, will set off multiple cell phone systems, but I think the airlines don't like it. So, but the regulation is still in place. No cell phones in the air. Okay, so let's talk about communications. If you have a big program, you have a tracking team, number of people that are out there tracking. The advantages to that, if you can get out to the landing site, or especially get your students out to the landing site, they can watch the balloon come down. And that's kind of the gold standard in my mind. If we can, students can launch the balloon, then we can take them out to where it's gonna land. And as we get out there, I start talking with the tracking team, and they tell me, it looks like it's gonna come down either over on this road or over on this road, and we take the students over there, and if they can see the parachute come down, and then we walk out in the field and pick it up. That's neat. And the other reason you want to have your tracking team out in the field is once the parachute lands, if you don't see it, you have to drive around and listen for it. Listen for that beacon to transmit, to figure out where it landed. If you're far enough away and the balloon is coming down, the last beacon you're going to hear from it is maybe 2,000 feet, 3,000 feet off the ground, and you don't know exactly where it's gone. You can kind of predict, oh, the wind's blowing this way. You can figure that out, but you end up driving around. So your tracking team drives around and listens for the balloon. Somebody picks it up and says, yes, I found it, or we know where it is, and then they come over and get it. And it's neat to have a tracking and recovery coordinator, one person in the team that sits up on the hill, listens to where the other people are and say, you know, Bubba, you go over to the east, and Bob, you go to the west, such that when the thing comes down, maybe somebody will spot it. Okay, so how do we do the communications between the folks out in the field? Well, UHF communication between the vehicles is the way to go. And we use the repeaters, the mountaintop repeaters here in the Denver area. We're really have an advantage of having mountaintop repeaters. There's a great repeater up on Mestahey Mountain, which you probably know as Squaw Peak, that works really good when you launch out in Deer Trail and it goes out east. Pikes Peak has a repeater up on the top of that used to be really good when you were down south. Unfortunately, the park department, who is it? Whoever owns the park up on the top of Pikes Peak, they remodeled everything and they told the hams, okay, you have to put your repeater back over here, and it's back from the edge of Pikes Peak, back on the far side. So all of a sudden, the beautiful view that this repeater had of the whole southeastern Colorado went away. And the Pikes Peak repeater really isn't very useful anymore. There's some talk about maybe getting it back onto the edge, the eastern edge, but we'll see. And then there's a few local repeaters out in eastern Colorado that work for us. Cedar Point, which is out near Lyman, has a repeater on it. Hugo, there's a repeater out there, and we can get our tracking and recovery team to switch to that.
What's the frequency for your phone?
Say again?
What's the frequency for your phone?
You're asking what's the frequency for the Hugo repeater? I don't know right off. Talk to me afterwards, we can look it up.
Okay.
Yeah, I don't have that handy. The problem is that even these mountaintop repeaters, when you get out east of Lyman, the repeaters start to get unusable. We have high gain antennas on the cars to try to maximize it, but you eventually get to the point where you're out of range of the repeater. So at that point, we have to go to simplex communication between the cars. And if you've got a coordinator out there, you know, they can coordinate the communications and we can all talk between the vehicles. And the neat part about simplex is it's an expensive entry for folks that want to get involved with this sort of thing, to get into the hobby. Handheld with a mag mount, and if you're out with the communications team, that works pretty well. You know, even an inexpensive handheld will be good for several miles, and you can communicate with the team and get involved. And if you're getting active, then the next step up is to get a mobile in your car, and a mobile that has APRS reception capability is worthwhile and pretty useful. Okay, and then we have a ground station, and the ground station is can be something as neat as a van. This is not a picture of our van, of van with, some seating locations in there, for communications, or it might be somebody that's back at their own house in bunny slippers that's, communicating. But the neat part about somebody sitting at the ground station is they're not driving. They can spend their time with the computers, looking at the prediction programs to see where the balloon's going to come down. They can study the maps carefully and radio out to the team that if you go to County Road J and then go south to County Road 7, it looks like it's going to land northeast of that. So that person can do that kind of concentration, or can concentrate and do that sort of thing. And the other thing neat they can do is they can summarize periodically over the air on the repeater what's going on. So if you're interested in following a flight, you could watch it on your computer on aprs.fi, for instance, and you can hear the ground station periodically summarize what's going on. So that's kind of okay, so that's all analog repeater FM stuff, but we have started using DMR more and more in communications out in the field, and that's because Rocky Mountain Ham has a network that you'll hear about at the Tech Fest that is pretty darn good. Rocky Mountain Wide route number 700 is a thing that lights up all of their repeaters up and down the Front Range, just clear from Cheyenne to Albuquerque. But they said, there's not a lot of activity on there. We welcome you to use that. So we do our communications there. But the beauty of that is that there are repeater locations up on Mount Thornton, on Mestahey Mountain, Almagre, which is right near Pikes Peak. There's a DMR repeater out at Lyman on Cedar Point. There's a DMR repeater out in Burlington. So that covers kind of the whole eastern part of the state. And it works out pretty darn well. In fact, it saved our butts when we were down this summer. We had a flight that left from Lyman and it went kind of southeast. And it was down near where we used to have Pikes Peak coverage. We don't have that anymore, but DMR did allow our team to communicate that way. And we've actually got a couple of portable Rocky Mountain Ham repeaters, one in our ground station and one out in one of our tracking vehicles that's connected via LTE telephone into the Rocky Mountain Ham network. And so out in the field, even if they don't have DMR coverage, they can still get it through this repeater. So some neat possibilities, but that means now you got to get a DMR radio in your car, a mobile in your car that'll cover that. So another piece of equipment, but hams like equipment, right? There we go. And if all else fails, you can fall back on the cell phone. You can use the cell phone for communications. If you've got the cell phone number of the tracking and recovery coordinator, you could give them a call. They can call you. You can track what's going on. If we're transmitting APRS from up in the sky and people are picking it up and putting it on the web, you can go to aprs.fi and see where the balloon is. We have our own, EOSS has their own website, track.eoss.org. You can go on there, and I tell the students, you know how to do this now, right? Track.eoss.org, and they can see their balloon, where it is, what altitude it's at, where it's coming down. And that works really great, assuming you have cell phone coverage. You get out eastern Colorado, depending on what provider you've got, you may or may not have cell phone coverage in certain areas. So if you rely on that, once in a while you're in a blind spot, but generally works out pretty good. This girl seems to be pleased with it. Okay, so that's communications on the ground. tracking the high altitude latex balloons. Now let's talk about the radios up in the sky for doing this sort of thing. First of all, you don't have to have a radio that's very powerful. Line of sight is a beautiful thing. When the radio's only 5 miles above 20,000 feet or 40,000 feet above you, a third of a watt works just fine for communications. Half a watt or so is plenty for doing that. Weight is an issue. I think we talked about that a minute ago, but the balloon can only handle so much weight. So we got to keep things fairly light. And historically, we have gone from heavier to pretty light now. Let me talk a little bit about some of the beacons that we used. One of the first, when I got going on this thing about 20 years ago, they were building some beacons. And here's a Linko credit card radio. It's a DJ-C5 radio. And the guys figured out how to take these apart, connect into the antenna and the audio input for it, and use this for a transmitter. And they actually figured out where on the circuit board to get in there and use it as a receiver. So you could communicate using that. And then eventually when these became unavailable, they started using some of the smaller HTs. I don't know exactly what model, but some of the smaller Yaesu HTs packaged up in a box like this to do the communications. As for GPS, back in the old days, here's a Rockwell International GPS unit. Has an external antenna, uses 12 volts, 5 volts, I don't remember. But a GPS unit that was in there. And then you also have to have a some sort of a computer in the middle to take the GPS data, format it into the correct format, and then turn it into audio and then transmit it over the FM radio. These Rockwell International GPSs, I bought one group of 5 of them years ago. And so I've got a couple of them here. If anybody wants them, they're free for the taking. That's the only thing on this table that's free. Don't take the rest of my stuff. Okay, but the current state of the art now is to use a radio module that is made in China. And this DRA 818V, it's a VHF radio, it's a transceiver module, about 1 inch by 2 inches. Transmits low power about, low power at about 0.5 watt, high power at 1 watt. By the time we have filters and antennas in there and everything, we're transmitting at about 160 milliwatts when it's up in the sky. And then when it comes down below about 20,000 feet, they turn the power up to 800 milliwatts. And the reason they do that is once the thing comes down and lands, it's a lot harder to hear. Once the antenna's laying on the ground and there's ridges in the way and that sort of thing. And that's where I'm saying sometimes it'll disappear. You won't hear a signal from it. You've got to drive around until somebody finally gets close enough to hear the signal. So if it's high power, that would help with that. I will show a picture of this unit in a few minutes, but here's the diagram of this thing. This is pretty cool. The transceiver itself, these things cost about $15 when you buy them from Japan or from China. It's got the RF transceiver in it. It's got a low noise amplifier, filters, going on out the antenna. The amplifier must be for, this is a receive thing. It's got a UART, so you can communicate with it via digital. It's got a microphone in and audio out. You have to put an amplifier on it to get it loud enough to be able to hear it. It's got a DSP circuit in there, digital signal processing circuit. It's got the CTCSS code circuits in there. It's a whole transceiver. In fact, to build a here's a typical application circuit to build a transceiver. And I think that's what they're using to build the Baofeng is one of these modules. You have a audio amplifier that goes to the speaker. You have a processor that talks to this thing and sets it up. The processor also talks to a LCD panel and a keyboard, and that's it. If you think about it, that's probably all that's in here is a processor, a screen, and a module like this. In fact, this thing has the same chip in it that Baofengs are using now. And we all know that, we all know that Baofengs are a little sloppy in terms of the signal quality that comes out and everything. I will talk about filtering that module in a minute. Pretty neat for 15 bucks. Okay, so the formats, what kind of formats do we use in the air to get this GPS information back down? You know, essentially all we need to send back down is the latitude, the longitude, the altitude, and then a comment field to put battery voltage, temperature, stuff like that in there if you want. APRS turns out to work pretty good for that. Remember, APRS was kind of a follow-on of the packet radio business. And they used to use the TNC, terminal node controller, hook it up to your radio, hook it up to your computer. You would find other nodes around and directly connect into them. Well, APRS does not directly connect into anybody. It just broadcasts using the AX25 protocol information. And there's a number of different APRS strings that can come out. The only one that I'm really interested in is the frame, or is the one that has the latitude, longitude, altitude, has the time, and the comment field. And we transmit that on FM radio. It comes down as a, I think it's a two-tone, what was that? Two-tone FSK frequency. I can't think of what it is. This is multiple frequency shift key. There we go. Right. Okay. Some people or some guys and gals in Australia, really smart folks, have come up with Project Horus was the name of their balloon program. They've come up with a binary protocol that I'm starting to see people use now. EOSS, of course, has not gotten into that yet, but you can use a SSB receiver to receive this. It's a multi-frequency shift keying thing, and it has forward error correction, and it transmits data about once every 3 seconds. APRS is typically once every 30 seconds. So once every 3 seconds, and they say it's about 7 dB better than RTTY is what they were using before. But it's a better protocol and gives you data on almost a real-time basis of where your balloon is. I've also seen people using amateur TV and then some commercial protocols, you know, like trying to use Wi-Fi. Students, especially, some will try to use Wi-Fi, some will try to use Bluetooth. And then now we're starting to see LoRa protocol or transmitters and protocols up in balloons. So a number of different formats being transmitted. Of course, you got to have a receiver that you built that'll receive that. And then another thing that we're using is ADSB. That is the this is the device that as of 2020 was required to be on all aircraft, all planes, both commercial and private. And if you go to FlightAware, or if you go to Flight Radar 24 on the web and you look up commercial flight, try to see where your cousins are flying right now, It's all using this ADS-B. And the regulations have started requiring ADS-B on drones. So the electronics have been shrunk down and gotten significantly smaller. The advantage of ADS-B is air traffic control actually sees that on their screen. And commercial planes, when they're flying, can see other planes on their screens and balloons on their screens if they're transmitting with ADS-B. The problem is these things cost about, this thing's about $2,000 at the moment. So that's not very good for an amateur program, a school program, something like that, or these pico balloons where we're trying to stay ultra light. And the reason I'm talking about this is because with the Chinese balloon scare, like a year and a half ago, Senator Kelly from Arizona proposed that all balloons that are flown have a method of identifying their location on them. And the push for that would be ADS-B on all balloons. And that would kill most of the programs in the United States. If you wanted to follow the regs, you probably wouldn't be able to do it as an individual. Most schools don't have the money to support something like this. And so actually the regulation that it was a House bill, and I believe it did pass. It says that the FAA will put together a committee to decide on how this should be implemented. And we're trying hard to get a representative from the amateur radio community, the amateur ballooning community, on that committee. I don't know what the status on that is right now. But all balloons actually do report their position, right? We're happen to be reporting it. Maybe it's only going to our computer, but it may also be going to the web if it's APRS. And it turns out, I guess the military is actually looking at APRS now and balloons, amateur balloons, and shooting down and all that stuff. Okay. I want to switch subjects now. We've been talking to this point about the high altitude amateur balloons that are latex, go up, pop, and come down. There's a whole nother world called pico balloons. And the reason they're called pico balloons is they started out by going to Walmart and buying a Mylar party balloon, filling it full of helium and launching it. And the neat part about this is actually a little more sophisticated by this from a scientific supply. It's 36 inches in diameter. And this thing is strong enough that if you only put a little bit of gas in it and you let it float up, it will go up and go tight. And it's strong enough that it won't burst. And when it goes tight, it's then becomes a super pressure balloon, and it'll float along just at that altitude. In order to make that happen, though, you better have a very light payload underneath it. You could go with a bigger balloon, but bigger party balloons are not easy to get. There are some people who are building bigger balloons. Found out if they make it out of the same plastic that the Japanese use to wrap sushi, it works good. But with a balloon like that, you have to have an ultralight payload. And this payload only weighs about half an ounce. I think this is 12 grams total. And it's solar powered, has two solar panels on it. And this thing under one of those pico balloons, and you can see Bill Brown, he actually built this. Bill Brown getting ready to launch it. And when he lets that go, this balloon will float up to somewhere between 40 and 50,000 feet. And then it will level off. And at that altitude, it's above most thunderstorms. Some thunderstorms will come up, and if it gets into a thunderstorm, that's it. It'll pull it down. But it'll also get up into the jet stream. If you can get it up into the jet stream, it will go all the way around the world. And this is an example of one of Bill's balloons that went around the world 7 times. The record was a balloon that just went down a couple of months ago, but it had been up for 870 some days. And he estimates probably went around the world about 48 times. Now, the reason he can only estimate it is because in the winter, it will push up into the north. You can see this one going up into the Arctic regions, and they'll go up into the north, and there's not enough sunlight up there to light up and turn on the radio, and it can't transmit its location. So some of them are estimates. There was a diagram of his, but I couldn't find it anymore. So, but the neat part about these balloons is you can get into this. Probably costs $400 for the equipment that you need to get into it. And Bill sells these things for $169 now, complete with the antenna. It's something that an individual could do. You could do for a elementary school class. You could do for a junior high school class. And then it's pretty neat, and they can track it.
What's the frequency?
20 meters. I'll talk about the protocol here. Okay, this is the balloon that I launched, actually, me and my EOSS buddies. This was KC0RPS-11. We launched it from Boise, Idaho, when we were there for a conference. This was in 2017, I think. And it didn't get into the jet stream, but it took off, and the winds took it up over northern Canada, and then about 1,200 miles off the East Coast down into the famous Bermuda Triangle. And it circulated down there for a few days in the storms down there. We watched it go from 38,000 feet down to 20,000 feet down to 10,000 feet. Oh God, that's it. And it disappeared. And so we thought that a thunderstorm had brought it down. Next morning, somebody got on the internet and said, it's alive, it's alive. It had come back up and floated around for another day or so and then disappeared for good. So the Bermuda Triangle finally got it. I do have one more of these, and so I'm going to launch it here someday, and we will hopefully get it going. Okay, let's talk about the formats that we use for pico balloons. Well, APRS is 2 meter APRS is one way to do it. There's lots of receiving stations around the world that receive APRS and put it onto the internet, so you can watch on the internet and see where your balloon goes. Obviously, there aren't many stations across the Atlantic Ocean, for instance. And so if we were to launch a balloon from here, we would be able to watch it go out east, and it would go off the East Coast. And when it gets about 150 miles out, then it disappears, or you don't get any reports from it. That's because it's out of 2 meter range. And then if you cross your fingers and the weather stays good, in about a week, it will start showing up over in Europe. Now, Europe uses a different frequency than we do for their standard APRS. First times the guys did it, they estimated their balloon was getting over toward the Azore Islands. So they got on the web and they talked to the hams over in the Azore Islands, and they said, tune your receivers over to our frequency, and picked it up. But this thing is actually smart enough to change frequencies as it works its way around the world. And there's 3 places in the world that do not allow amateur radio in the air. One of them is North Korea. One of them is Somalia or something like that. And one of them is the United Kingdom. Turns out UK, that's probably left over from World War II, but they do not allow amateur transmissions up in the air. So the guys over there that fly balloons have to fly them on 915 megahertz unlicensed frequencies. But I guess I've heard that the regs in the UK, the new regs are going to drop that requirement. But anyway, this thing is also smart enough to be geofence such that when it hits North Korea, it will turn off, not transmit as it crosses over North Korea, and then turn back on the other side. Okay, so APRS is one way, different frequencies around the world, and there's that limited distance issue. In fact, here's an example of that. Here, yeah.
What happens if you retransmit what you're not supposed to?
Probably nothing, but hams pride themselves, I think, on following the rain. Shoot down, we can talk about that, yeah. You would wanna, well, you wouldn't wanna piss off Kim Jong-un or whatever his name is, but, yeah, they probably wouldn't know. Okay, but here's an example of a 2-meter balloon, and it flew across the Atlantic. Here it's Turkey, so the Mediterranean Sea is down here, right? This is the Black Sea up here, and it flew across Turkey. Now, the reason that didn't see any reports from it here is, number one, it could have been at night. Remember, at night, it's gonna go to sleep. It's not gonna transmit, and then the next morning it wakes up, and so you just connect the dots. Or possibly there were no amateurs in Turkey that were monitoring APRS frequencies and putting them on the web in this case. But then when it got here, these guys up here started picking it up. You can see the red dots are where position reports came. Thing came up here and kind of curled around, and then it started out into the Black Sea. But when it finally got out here, this is about 150 miles. So even if there are folks around here that monitor this sort of stuff, they couldn't hear it because it was out in the ocean. So APRS has its limitations. So what's the solution to that? It's to use the WHISPER network. WHISPER is this weak signal propagation reporter system developed by Joe Taylor, same guy that developed FT8, and has a Nobel Prize for signal processing stuff. And the way WHISPER works is you transmit a low power signal from your antenna, and then people around the world monitor for that. When they hear it, they put it onto the WHISPER server, goes onto the network, and then you can look and see how good your antenna actually works. And WHISPER can be done on many frequencies, but we're using 20 meters. Why? Because 20 meters is good during the day, and your transmitter works during the day. So there's many receiving stations around the world. They put it on the web. Long range transmissions, which gives you a good chance of seeing it. But one of the disadvantages is you have to have a half-wave dipole antenna. So that's a 20-meter dipole. It's what, 33 feet long? And so the way this is in fact a WHISPER unit. And the way this thing works is you have the balloon, you have 16 feet of number 36 magnet wire with a little nylon fishing line wrapped around with it for strength, hanging from the balloon. And then down below this thing, you have 16 feet of wire. So it's a dipole with this thing right in the center. And that's what flies. It's a little bit tough to launch, but once you get it launched and up in the air, it works pretty well. Here's an example of WHISPER, for instance. Here's a station in Spain that is transmitting, I don't know what power he was using, but transmitting WHISPER, and then all of these stations are reporting having heard that signal. So if you have a balloon flying along, it reports that. That's pretty good. Now, unfortunately, all WHISPER is set up to do is transmit your call sign, the grid square, and your transmit power. And it takes 111 seconds for that protocol to transmit that information. So what they've done with these things is they only transmit once per hour. And when they do transmit, and Bill Brown, I think, developed this. What they do is they'll transmit this first one with the call and the grid square. And instead of the transmit power, they might transmit the battery voltage, for instance. And then they transmit a second string. In the second string, they use a fake call sign. If a call sign starts with a Q, or if it has a 0, if it starts with a Q or a 0, there's no countries in the world that use that call sign. So if the whisper system sees that, I guess it still puts it onto the server. But then you can instead of in the call sign, you started with a 0, and then in it you encode the battery voltage. And then instead of the grid square, you transmit instead of the 4-digit grid square, the 2 additional digits. And you can put the rest of the information in there. Then you have to have a Python program or something running that goes out and looks at the Whisper server, pulls those things off, puts them all together, and then what they do is turn it into an APRS string and put it on the APRS. So you can go on the APRS and you can follow your balloon along. But it's using this Whisper protocol, which transmits pretty well. This was the first one that I launched. I put a 20-meter ham stick out in my front yard, hooked up the beacon to it, started transmitting, and I was getting folks all around the United States here that were hearing my signal. And I, in fact, did get one shot over into Europe that did hear my signal. So that's the transmitter that we ended up flying. So this Whisper protocol works pretty neat for pico balloons. So what do you use for a pico balloon beacon? Well, one answer is the Sky Tracker that Bill Brown, WB8ELK, makes. And when he built this thing, the idea is to make it as light as possible. So instead of the usual 1 or 2 millimeter thick circuit board, this is a 0.5 millimeter thick circuit board. You can go thinner when it starts costing more money then. The solar panels here are plastic. He's peeled the back off of it, so it's just a plastic solar panel. You can use the crystalline solar panels, but he said if you're passing this around the room with a crystalline solar panel, they ain't gonna last very long. He's using the very small surface mount stuff, the brass tube that he used. He started at the hobby shop with 10 or 1 mil thick tubing, and then found out he could get 0.5 mil thick tubing somewhere else. So it has a GPS on the front of it with a little patch antenna processor. For the transmitter, he just uses an oscillator. And then use a filter to filter out the high-end stuff. And on the back, it has a super capacitor. And that super cap, I think, is a 0.5 farad at 5 volts. He said he discovered if you only use a 3-volt super cap, you put 5 volts on it, they make a very loud pop for a while.
It keeps it alive when it's starting.
Well, no, it keeps it alive so that it can get its full transmission out. These solar panels will generate like 5 milliamps or something like that. But during transmission, I think what he actually does is he turns off the GPS, so you don't have the power requirement for that. And then the transmitter comes alive and transmits. And SuperCap helps keep it alive so it can do the whole 111-second transmission. Why don't I go ahead? I'll go ahead and pass this around. Please be careful with it and take a look. But there's a couple other versions of that around. QRP Labs is a real smart British guy that happens to live in Turkey. And here's his beacon. Obviously it's going to need antennas, it's going to need solar panels, and it's got a processor on it that you actually So you can go in there, and I think you use basic to actually go in and put in the program that you want to be able to process and everything. And it has a USB connector on the bottom. When you get it all programmed, you go ahead and break the USB connector off, and then the whole thing only weighs a couple of grams. And you hang that under a balloon, and away you go. That is this guy right here. And you can see the processor there. So I will go ahead and pass this around. Don't drop it. Good. Okay, and the third one I've got, I don't have an example here, but this is interesting. It's called a traquito. It's a combination of track and paquito for small. Turns out there's a mineral called traquito that they have in South America or something. Anyway, you go out to this traquito.github.io and you find the details on their beacon, about the same as the Sky Tracker in terms of size. Well, first of all, the few other things that you need. You got to have a balloon, so you got to buy the balloons. You got to get the solar panels for it. You got to get some hydrogen or some helium for it. And if you go to Walmart and buy the helium there is now environmentally friendly. It's only 80% helium and 20% air. So it doesn't lift quite as well. And you have to take that into account, and it's only going to float at like 35,000 feet rather than 45,000 feet. Turns out they have found out that there's somebody in, you can go on Amazon and you can get something that comes from Germany that's a balloon tank like that is 100% helium. The other thing you can do is go to a welding supply. If you have a small tank, welding supply will fill you up with helium. That's good. You still have to have the tank though, and either rent it or buy it. You have to pre-stretch the balloon. If you just let the balloon go up as it is now, it's been folded up, the edges are stuck together. And so what you do is you actually pre-stretch the balloon with using like a aquarium pump it up, use a manometer to get about 1/4 PSI inside it, let it sit for a few hours, and that stretches the balloon out. Then you collapse it, you gotta suck the air out of it with another pump, and then fly it. And then when it goes up, it'll go up to that altitude. Incidentally, at night, when it cools off, not only does the transmitter quit, but it cools off and it'll drop a couple thousand feet. And then the next morning when the sun hits it, it'll start to come back up. And then finally, when the sun angle gets good enough, it'll start transmitting. And then you got to buy wire to make your antenna. So there's some of the goodies that you need to buy to get going there. But the Traquito, this is kind of interesting. What it is it's based on a Raspberry Pi Pico, which is a small, size of a pack of gum kind of a thing. You can buy it from Adafruit for $4. It's a full-blown Raspberry Pi. And then you have to get their add-on module that you put onto the Raspberry Pi. And the two of them are soldered together with the pads that match up with the pins there on the Raspberry Pi. And the Raspberry Pi plus the add-on module makes what they call the jetpack. And then you drag and drop to get the firmware, you hook it up to your Windows computer, and then you drag and drop the software from the website into your computer, and it loads it onto the Raspberry Pi. And then to configure it, you're hooked up to your computer, and then you go onto their website, you put in your call sign and that information, and it programs it. I guess the software is not open source, but it comes down automatically and goes on to here. The interesting thing is the jetpack cannot be, the add-on module cannot be purchased. What they do is they give you the files, and you have to go to JCL-PCB, which is one of these Japanese, Chinese circuit board manufacturers, and make the circuit board and populate the circuit board over there. The way you do that, the Gerber files, those are the files that the PCB design software kicks out. And they give you the Gerber files, and so you go to JCL PCB and say, I want this circuit board made using these Gerber files, and they'll do that. And then you give them a bill of materials. They have about, I think they say 500,000 parts, different parts in their inventory. And if they've got them in their inventory, they will load them onto the circuit board for you, using the bill of materials and then the CPL files, which are the files that tell the machine where to place the part on your circuit board. And so you send all this stuff to them and say, I want, if you buy just one, it's going to cost you a little bit, it's going to cost you more. But, you know, somebody I read just recently, they ordered 5 of them and it ended up only costing about 35 bucks. So that's about $6 a piece for these things. But it's kind of interesting. The website actually steps you through how to go to JCL PCB's website, put these orders in, pay about 20 bucks shipping, and they show up at your door. You solder that together with the, so I haven't done this yet, but it's an interesting sales model. I'm really surprised somebody hasn't ordered 50 of them, sells them for, 25 bucks each or something. But as of right now, you order this thing and away you go. Okay, there are people that are flying the Trapedo right now and are going around the world with them. Okay, what about shoot downs? That's a popular issue here with the military as well as us. Right after the Chinese scare, there was 3 objects that were shot down. We know for sure that one of them was shot down over the Yukon, and we highly suspect K9YO-15 was the beacon. This is a group of guys called the Bottle Cap Brigade in Illinois that launched this balloon. It was flying around the world, and the way we think it was them was here was the location of the balloon the evening before the shoot down. Okay, it was coming across from Japan, coming across this way, and the last report they got from it was right here on the coast of Alaska. And so some people looked at the wind modeling for that altitude up in Alaska and predict that during the night, this thing, remember during the night, it's not going to report, but during the night, it would have flown across Alaska and then up into the Yukon to this location right here. And the military says that at 2041 UTC on February 11th, they shot down an unidentified object over the Yukon, somewhere near between Dawson Creek and Mayo, and everything matches up for it to be that balloon. The military then went down to the ground and tried to find search for the thing, but they never found it. Considering if it's something like that, what's the likelihood? Number one, they're going to find it. I don't know if the $400,000 Sidewinder missile that they used actually blew up and vaporized it, or if it just pierced the balloon. But
How do they know where it is? From the signal, that's too small, obvious to see it, right?
they were apparently seeing well, at that time they were using the Mylar balloons, and the Mylar balloon is reflective to some degree. People now are using the clear balloons, probably for that reason. Yeah.
So, let's see, why I spoke to, wouldn't the AWACS plane pick that up?
I have no idea. That may have been what they picked up.
Because they monitor.
Yeah.
And it says out by the signal and the frequency, there is IFF or identification kind of thing. So this is how they determine whether they're.
Okay,
If there was a phone frequency that should out,
okay.
if there's a primary, then they'll tell.
You're saying that it should identify itself as either friend or foe,
Yeah,
or friend or not. I don't know. You know, obviously this didn't identify itself. My understanding is that the military radar generally did not pick up balloons. It was tuned to look for big metal planes. And after the embarrassment of the Chinese balloon flying over the United States, they retuned their radars to make them more sensitive. And that's when they started seeing this sort of thing. So I don't know any more of the details than that. But the next picture I've got, I think is still classified, so I'm kind of worried about putting it up, but the military has come up with an alternative for the Sidewinder missile for taking care of these balloons in the future. Now, there was another balloon that was over the Lake Huron that we think might have been an amateur balloon, but the balloons that we know about, the timing wasn't quite right to match up like this one did. I did meet that guy, KY90 or whatever his call sign was, at Dayton, but he was very reluctant to talk about the balloon in this issue. I don't know if his lawyers had told him not to talk about it, or if he's worried about going to jail or what, but he wasn't saying too much about it. Okay, so if you want to build your own beacon, let me tell you a little bit about that. If you want to build your own beacon, what you need to do, if you're going to have APRS coming down, you got to have a GPS in it. You got to have a TNC or some sort of a computer in the middle to put together the string the way you want it. And then you've got to have a transmitter to transmit it. And then if you want to send commands back up, for instance, to cut down the balloon or to actuate some sort of experiment or something, you need to have a receiver. You need to have a DTMF decoder to decode the signals from your radio, and then an actuator to do whatever you want to do. And showing you the transceiver that we had before, we got the transmitter and the receiver ready to go. So this is a beacon that guy has put together, a couple of guys have put together for Edge of Space Sciences, and I want to show you a little bit about this. It's kind of neat. Here's that transceiver module that they buy for 15 bucks. He says it's a little frustrating because the processor sends it commands to set the frequency and tell it when to transmit and what to or configure. But then he said there's no ability for you to read the configuration back out, make sure it's set up correctly. And I guess as a programmer, that's frustrating. There's a button cell to keep the real-time clock alive. Here is the GPS module. So it's gotten quite a bit smaller than this Rockwell International thing that I had up here. GPS module, and then here's the GPS antenna. They use a separate antenna that's mounted on the top of the thing to look up to the sky all the time. And then this is a Bluetooth module that's been soldered in place here. So, and the Bluetooth antenna right there, so that this device can talk to the actuator, which is further up the flight string. And also you can talk to this with Bluetooth and a tablet to program, configure the thing. Okay, so then on the back side, you've got the processor, you've got some additional EEPROM memory to store stuff. You've got the power supply up here, and then feature creep, of course, you've got to put more stuff in it, right? So here's an SD card for logging all the information as it's flying. Here's a power connector for programming it on the ground. Here's a USB connector to hook up to it for programming. So it gets a bunch of things put in it, but they put this thing together It's got the GPS, and you have to send the GPS setup commands, to get it going. Now you have to have a TNC, which is the computer, but, why buy a big TNC board, put it in here, build your own. So it's got the two FSK, it has to generate the frequencies, the audio tones for the frequency shift keying. It has to generate the AX25 protocol. It has to put together the APRS string and then send that to the transmitter. So that is all being done in software in this processor here. And guys are a lot smarter than I am, trust me. Okay, then the transmitter, you have to send it the setup commands. And then you've got the issue of the clean signal coming out of the transmitter. Remember, like I said, that radio module uses the same chip as the Baofeng. And this thing is dirty. In fact, what I did was, well, first of all, when I got this nice certificate from the Chinese. And it says, herewith confirmed and found to comply with the requirements of ANSI C63.4 and FCC Part 90. Part 90, that's the commercial radio, isn't it? Aren't we Part 97? Regulations, okay, but there's a certificate, so it must be good. And when I was at Dayton, the ARRL had a spurious emissions booth. And you could bring it up, you could bring your radio up to the booth. And they copied down your call. They said, we don't send this to the FCC now. They copied down your call sign, the date, manufacturer. They did actually publish an article where they summarized all these things. But they measured 1.5 watts output from this. And they said, okay, that the second harmonic needs to be at least minus 47.5 dB below the main signal. And when they measured it, this was only down 35 dB. It's supposed to be down 47.5. It's only 35. So they said, well, it doesn't pass. They said, but all these valve things don't pass. And they signed it, and notice they never actually checked if it passed or it failed. I said, you're going to take it away from me now that it doesn't pass? They said, no, we're not. But what they were doing was ARRL was collecting all this information on these various radios by manufacturer and everything. But anyway, this demonstrates that this thing doesn't pass. So you would suspect that the transmitter on this thing might have that same problem. And in fact, they discovered it did. And so he put a low pass filter right in this area of the board to cut out that second harmonic and keep that down. I don't know if it would really cause a problem, but we want to meet the regulations. So I asked him about designing this thing, and I thought this was kind of interesting. The first thing he did, well, if you want to learn about this, SimSmith is this program that designs circuits, and it generates Smith charts. And a guy has put together a whole bunch of SimSmith basics videos. I think 27 of them or something. But if you go to video 11, it's about designing filters. And it's exactly the process that this guy went through to design the filter to filter that out. And what he did was he first developed a filter design, and there's a program on the web called LC. And that sounds like LC, the parts in a filter, and it's free. You can use it on the web, and you can say, I want to develop a 5-level filter for transmitter in here, signal out here. And then it will develop the circuit, and it'll give you the circuit, the component values that you need to use. And then this guy in the video says you put that into SimSmith. And when you put it into SimSmith, you can put in the values here, and then you can tweak them. And when you tweak them, you have some curves that SimSmith generates that shows you how good it actually is at filtering. And how you tweak it was beyond my level of knowledge, but he said, okay, if you need to move this front end up, you change the value here, and then if you need to do this, you change the value over here. So got to learn a little bit more about it. But what he did was he tweaked the various values here, and till the curves that SimSmith generated were to his liking. And the Mark, the guy that developed that board, then went to a program on the web called TINA. And TINA is a analog circuit modeling program. And apparently there's a free version of it. There's a subscription version of it that you can buy that's full featured, but there's a cut down version of it that's available free. I don't know if that would meet your needs. But what he was able to do was then put this circuit into TINA. And you can see he set a cursor right here at 144 megahertz. That's the primary frequency. And then he went out to the second harmonic here and looked at the value there. And if the value running here, he actually used his analyzer, spectrum analyzer to look at the power output. And the power output here was about minus, what is that? 10, 20, well, that's 25, 5, 10, 15, 20. Anyway, this was the measurement of the primary. And then he could see that at the second harmonic, it was down about minus 62 dB. Okay, you gotta be minus 40, 47, something like that. Yeah, I couldn't quite, I've looked at the reg and I can't quite figure it out, but minus 47, so he said, this ought to be good. So then he built the example of it and put it on his spectrum analyzer. And here is the primary frequency at 144.490 megahertz. And then here is the secondary, the delta marker at 288.461 megahertz. And you can see that this one is down 62.79 dB from the primary, which is exactly what that modeling program showed. So unless he fudged this whole thing, it looks like it acted just the way he wanted. So this is the kind of thing that I wish I was smart enough to do on my own. Pretty cool.
Jim, did he say how the heck you could realize it at those specific capacitor and inductor values?
Oh, he's asking the exact capacitor and inductor values. Well, obviously you have to buy the inductors and the capacitors in the values that are available. And that may have been part of the tweaking in SimSmith, is that it only allows you to put in values that are currently available. But anyway, he found one that that met the need. And you can see, you know, obviously this filter works damn good down at this frequency, but here's the frequency he was interested in. So that may have been a limitation of what components he had available. You know, ideally you'd want to move this over and have it right there. Okay, so the final thing I think I want to talk about here is the mechanical issues associated with building a beacon like this. Obviously, if you're going to only fly it once, you know, build it on a circuit board, or actually I've seen some of the students try to do it on a one of the not perf boards, what are they called? The white development boards where you plug in the wires. And they tried to fly that. I said, no, you got to use a lot of hot glue if you're going to do that. But this is something that EOSS is building to try to use over and over again. And some of these have flown literally 100 flights. But in order to do that, the kind of things you need to think about. First of all, they said minimal wiring you can see there's very little wire. In fact, the connections between these two boards are actually pins that are soldered in place. No wires. The only wire is the power connection that's coming right there. Mechanical attachment. Connect the boards together. Plastic separators don't work. You got to use metal separators, because think about it. This thing's hitting the ground probably going about 12 miles an hour, and the accelerometer chip that's on there has registered about a 10G impulse when it hits the ground. So, you know, they hit the ground pretty hard. Top and bottom protection, I'll show you in the next picture, but when the thing hits the ground, it's most likely going to hit the ground bottom first. Antenna attachment. You attach the antenna using screw connectors that are on tight. Battery attachment. Show you a picture in a minute of the batteries, attaching those so that they stay in place. Use locking connectors so that when it connects together, it stays together. And then the trick is, don't open it up. Figure out how to turn it on and off, how to attach the antennas, and how to program it from the outside. So you're not opening up the box. If you don't have to open up the box, you minimize the risk of hitting some of those things. Okay, here's an example of the top and bottom protection. This is a piece of Kevlar or some sort of a plastic, stiff plastic material that's not brittle, that bends, and there's a piece on the top here and there's a piece on the bottom here, so that most of the stress is taken there. We also have a through tube that goes down through the middle, and you put the string down through there, tie a knot in the bottom, tie a knot in the top. That's how it hangs below the parachute, or hangs below the balloon. And so all the stress is handled by that tube rather than the circuit boards themselves. Put an indicator LED on the outside, put a switch on the outside, and this is a switch that you can't accidentally bump just before you launch it. You bump it, it turns off. It's not going to work again for that flight. There's a battery charging connector. There's your antenna. Get it all on the outside. Make it colorful so that when it lands out in the field, you can see it. And then one problem we do have is we use a J-pole, twin lead J-pole for 2 meters. It's about yay long. And piece of coax comes out with an SMA connector on it. You screw on there, but if it gets bumped around, that can come loose. So you got to screw that on and make sure it's cinched down tight. And develop it that way. Okay, the final thing I want to talk about here, I think, is the receiving station. How do you go about receiving these things out in the field? If you want to go out in the field, well, the simplest way is to use your cell phone. Use one of the either APRS programs. Go on and look at aprs.fi or track.eoss.org. Follow the balloon that way. If you are following your Pico balloon, you could do that. If your Pico balloon is being processed and turned into an APRS packet, put on aprs.fi, you ought to be able to see it there. If you want to get really adventuresome, get your DF antenna out, get your handheld out, go out in the field and try to track the balloon that way. One of the catches is you have no idea how high it is. I remember getting out there one time with my DF antenna and going, wait a minute, I don't know if it's, how high it is, where it's going to land. Fortunately, I had a guy with me who was a cartographer for USGS. And anyway, I was feeding him information and he was plotting it on the chart, and we actually found it. But you can track the things that way. You can track the things with APRS capable radios. There's some handhelds that are out there, and that'll tell you that the balloon is at an altitude of such and such, and it's at a bearing of such and such, and it's 3.7 miles away. So you can use that to, and I have actually tracked out in the field, using a mobile. For a mobile radio, here's a Yaesu, one of Yaesu's latest, but it'll run APRS. It'll track it, and it'll tell you how far the balloon is away from you, what altitude it's at. You can chase it out in the field that way. If you want to get a little more sophisticated, get yourself a FM receiver, and one of the simplest ways to go is with an SDR dongle. Like this, and then hook that up to a computer. The computer, you can either have a TNC that decodes the information coming out of the receiver, or there's a piece of software called Direwolf. And Direwolf is a software implemented TNC. So you can do everything in the computer using Direwolf. So you can feed that, the output of that SDR into something like one of the SDR decode, one of the SDR receiver programs. And then the receiver program sends the data, the signal over to Direwolf. Direwolf then processes it, and you can use a mapping program to put it onto a map so you can actually see what's going on. A number of the mapping programs that are around, UIView is one that Roger Barker developed years ago and is still available. APRS IS32 is a program that runs on a Windows computer. Pinpoint APRS is another one that runs. YAAC, yet another APRS client, is available, and they say it is mostly platform independent Java application. I've never implemented it myself, but I've heard people using that. And then if you're a Linux person, Zaster is a program, and then here's a example coming out of Zaster, and all of these use open maps or something like that to map the stuff so that you can have it, so you can see it. You can go out with your car and chase your balloon that way, or participate with other folks chasing your balloon. This one looks like it's in a neighborhood here, so landing a balloon in a neighborhood is always interesting.
That's fine, Gordon.
Okay, that's what I've got, unless you want to hear 5 more minutes on weather balloons. He says weather balloons. 5 more minutes, then it'll be new. Weather balloons, the Weather Service launches balloons to collect atmospheric sounding data for their use. They are hydrogen filled or helium filled balloons, a parachute, 75-foot long string, and then just a beacon on the bottom. Here's an example of the circuit board out of one of the beacons. The old beacons, got a temperature sensor, it's got a 400 megahertz J-pole antenna, and it's got 3 batteries on it. If you turn this thing on right now, it would transmit. Weather services pick it up. Here's one example. That's an older technology. The things are getting much smaller. Right now, they launched the balloon and they use just something like this under it. This is a 400 megahertz. There's the antenna sticking out the bottom, the temperature sensor on it. And something like this, they don't even use a parachute. This thing is so light, they just let it fall with the string attached and figure that won't injure anybody. The hams have figured out how to open this up, change the frequency into the ham bands, and either do APRS or that Horus protocol, transmit from these things. So hams are flying this now, and it's free. They say these just fall out of the sky. Unfortunately, they don't launch them here in Denver anymore. We used to go out and chase them. They quit launching them from Stapleton because of hydrogen issues, I guess. Couldn't get helium. And so we had to go up to North Platte, Nebraska last summer to chase them. But this is all the places in the world that they launch radiosones twice a day. There's a lot of them out there. Here's all the places in the US where they launch, US, Mexico, Canada. where they launch balloons every day, and it all goes into supercomputers in the weather service, and they use them. They're always launched so that they're up at their peak at 00 and 1200 UTC. And when they come down, you go out and grab them, and there's the parachute. Little plastic parachute, cotton string, so that if the cows eat it, I guess it's not bad, or as bad. Here's the old fashioned one. This is the box, styrofoam box that circuit board comes in. Here's another one of the newer model ones. This one was launched in Crested Butte and flew over here to Denver, and I saw it coming over and went down and grabbed it. And I also have the programming cable for it. Gonna take it apart, program it to use again. Here's the diagram that the Weather Service puts together. This is temperature. Let's see, this is dry bulb temperature. This is wet bulb temperature. And from this, they can determine what the atmosphere is like, the likelihood of thunderstorms, cloud formation, all that sort of stuff. Here's the wind data that they get from it, and then a whole bunch of atmospheric parameters that they get from it. Somebody told me if you understand this diagram, you'll understand weather in the atmosphere. I'm not there yet, but I'm working on it. Yeah. Here's what they look like. Again, go up to about 106,000 feet, 110,000 feet, burst, then come on down. A little bit slower than the big latex balloons. And here was the one, I don't know if this is the one I thought or not. No, but anyway, here's one that was launched from Crested Butte. The wind was blowing this direction. It was right over Breckenridge at the time. And then there's me standing there with my catcher's mitt, getting ready to get it.
Does NCAR launch any of these?
NCAR, the Weather Service in Boulder, I think it's Weather Service, not NCAR, but I'm sure NCAR does. Yeah. Once a week from Boulder, they launch an ozone summit that monitors the ozone levels. And here's the gear I use to chase those balloons. Raspberry Pi with software in it that's been written by those guys in Australia. An SDR dongle with a mag mount antenna and a GPS module. And I have programmed this thing such that it generates a Wi-Fi hotspot. That Wi-Fi hotspot I can pick up with my tablet sitting up in the front of the car, and it shows me a map of where the balloon is, where it's predicted to land, and I take off in my car and go for it.
So you can get that programming on the internet?
Yes, the programming is available on GitHub, and there's instructions on how to compile it. In fact, they put together a module now that you just essentially load into the Raspberry Pi. It's not a whole operating system, but a pretty neat way to get it. Yeah, here's an example. Here's an example of the weather balloon. This happens to be Adelaide, Australia, but weather balloon took off and went up, and it's right here, and that is at 19,022 meters. And if the balloon were to burst right now, it would come down on this red line, and that there's a little star right there that is the predicted altitude that it'll burst at. If it bursts at that altitude, it'll come down to that one. So that's the kind of thing you've got. So you get in your car and you take off. This guy looks like he's way behind schedule, but you roar out there and try to get out around here to get it. And then this is a whole week's worth of them. This was from Grand Junction. They do launch in Grand Junction. The one that is going to be the one that's going to go at 6 o'clock this evening is number 1. The one that's going to go at 6 o'clock tomorrow morning is number 2, 3, 4, 5. So you can see where all of those are and figure which ones I want to go chase and which ones I don't.
I'm saying if you take steel
Steal them? No, because Weather Service does not want these back. Used to be, this one said, I think this one does say that if you bring this back to Crested View, we'll either give you a cup of coffee or an ice cream cone if you return it. But, no, they don't worry about getting these back. And I'm guessing they're probably having these made, by the thousands for, what, $50 a piece? Something like that. But then there's sonedhub.org, which is, where everybody puts their radio soned information when they get it. And you can see all the different balloons that are being tracked by amateurs around the world. One guy up here in Anchorage, probably, the Australians doing all of theirs, South Americans, South Africa does that. I don't know if they launch many others in Africa or not, and then Europe, a bunch of them in Europe. But this thing is kept up all the time. Look at how many are being done. And it's fun to do. Look, there's George, outstanding in his field. Problem is, it's like 7 o'clock in the morning, and I'm not gonna go up and knock on the farmer's door, and go, hi, can I go out here? Run out the field, sneak it, run back. Haven't gotten shot at yet. And, this was, one day when it was, nice and cold. I was out there, but, successful getting that one back, so. That's it.
Thanks, Jim.
Yeah, Jim.
1952, I was a little kid in Arizona, or in Tucson. I was in the backyard and a balloon, it did not burst. It was deflated coming down, and it had a package underneath the size of a shoebox. And my dad was home that day, and I was screaming, Dad, Dad. And he come out the back door and he saw this thing, it was big. And I remember it to this day, and it was laying up against our wall in the backyard. And he went over and poked it with a broomstick. And nothing happened, so then he went over and picked it up, and it was the size of a shoebox. And on the side, I remember with writing, he got very excited, turned it in for $50. 1952.
That's good money.
$50 was really good money. So when he got the money, he took us out to dinner.
All right. I talked to some ranchers out in eastern Colorado, and they used to say $35 if you packaged it up and mailed it back to them. Like some of them even had a mailing envelope attached.
Yeah.
And they said, I've sent several, and he said, never got a stamp. So. Huh?
How many cars you go?
Yeah.
I don't know how many cars, how many vehicles you go on.
As far as what? How many vehicles?
Chasing balloons.
Well, on the big US or on the big EOSS flights, we have somewhere between 5 and 10 cars that are out there tracking.
You use your car?
Yeah. Yeah, I have radios in my car and used to have a computer mount and everything.
How many miles are in your car?
330,000. Okay,